Hello everyone, I am Dr. Alok Agrawal, Associate Professor in the Department of Mechanical Engineering, Sadar Institute of Research and Technology. So in this video lecture, we will be discussing about power transmitting turbo machine and we will be discussing in detail about fluid coupling. So we have already seen that there are three categories of turbo machines. The first one is power generating turbo machines. Turbines come in that category. Second one is power absorbing turbo machine, which consists of compressor, fan, pump, and other things which absorb power. And the third category of turbo machine is power transmitting turbo machine. What is happening in this power transmitting turbo machine? That power is not generated, not absorbed. It is just transmitted from one shaft to another. That is, it is transmitted from driver shaft to driven shaft. And for transferring this power from driver shaft to driven shaft, we will be using a fluid. So this will took place. This phenomena will took place with the help of a fluid. Okay. Now, in turbo machine, there is no change in enthalpy of the flowing fluid. That is, the enthalpy of the flowing fluid will remain constant. Okay, and the fluid is in a rigid casing, which is confined in a boundary, and it is not allowed to cross that boundary. Like in power generating and power absorbing machine, what is happening here? There, the fluid can cross their boundaries. Means fluid is coming and it is interacting with the turbo machine and it is going somewhere else. But here in power transmitting turbo machine, the fluid is not allowed to cross the system boundary. And this is equivalent to the mechanical device. But what is happening here? Here there is no positive drive because driver and driven shaft are not mechanically connected. Here the shaft are not mechanically connected. We have seen the clutch and gearbox. What is happening there? The two components are in contact with each other. But here in power transmitting turbo machine, the two parts are not in contact with each other. They are distinct apart and they are in contact with the help of a fluid. So this work, this power transmitting turbo machine are classified based on the working principle, whether the machines are working on the principle of hydrostatic or on the principle of hydrokinetics. If it is working on the principle of hydrostatic, means the fluid will remain at static state, means it is not continuously move. While when the machine is work under the on the principle of hydrokinetics, what is happening here? There is a continuous movement of the fluid. So there are two examples of device which works on hydrokinetic, that is fluid coupling and torque converter, and there are various other device which work on hydrostatic principle. We have to learn here four, that is hydraulic press, hydraulic intensifier, hydraulic accumulator, and hydraulic frame. So in this video, we'll be discussing power transmitting turbo machine that works on the principle of hydrokinetics, and in that we will be discussing this fluid coupling. So what is fluid coupling? See, we have seen mechanical clutch that is used in automobile. This fluid coupling is very much similar to mechanical clutch. The only difference is that in mechanical clutch, the two components are in contact where the power need to be transmitted. But here in fluid coupling, the transmission of power took place from driving member to driven member without any physical contact or without any mechanical linkage. It is taking place purely with the help of fluid. Okay? So what is happening here? What is the advantage of doing this? With fluid coupling, there is no mechanical contact, so there is no shock while engaging and disengaging of the clutch. Further, the driver and driven shaft will not be encountered with excessive stress because suddenly it needs to be engaged in mechanical clutch, so there will be a torque, excessive stress in the shaft, which is avoided in fluid coupling. So let us see what are the principal components of fluid coupling. Fluid coupling mainly consists of two components. The first one is pump impeller. Pump impeller is the device, it is a rotating element which is attached to the driving shaft of the prime mover. Whereas second component is turbine runner, which is attached to the driven shaft. Means we give energy to pump impeller, and with that pump impeller will transfer energy to the turbine runner, and in this way the power is transmitted from driving shaft to driven shaft. These two components are enclosed in a single casing which is filled with fluid. Generally, we use oil as the working fluid because of its high viscosity, high lubricating power, its availability and stability. Okay, so this is the main construction of fluid coupling, where the driving pump impeller and turbine runner will not come in direct contact with each other. There is a some distance between them, and it is in contact with the help of a working fluid which we have taken oil. So this is the main component of fluid coupling. So here it can be seen how it works. See, it can be explained with the help of two fans. The one fan that is in blue color, we have we have supplied power to it. It will start rotating. Once it will start rotating, the air in between them get energized and the air flow from left to right. When the air flow from right to right, this air go and strikes the blades of the fan which we not supplied with electric current, or we have not supplied with power. So after some time, what we will see that this blade also starts rotating. Okay, so this is how the power is transmitted from this shaft to this shaft with the help of a fluid that is air. In the same principle, our fluid coupling works. Here, it is enclosed in a casing like this, and in place of air, we put here oil. So, what is happening here? When we start this blue component, that is prime mover, which is also called driving member, when we start giving energy to it, it will start rotating. Okay, and when it start rotating, it throws oil because of centrifugal action. Once it throws oil because of centrifugal action, the oil will not allowed to move circumferentially after certain distance, so it will move from left to, and this oil get entered to the turbine runner and exert force on the blades of the turbine runner. The magnitude of torque increases. This torque increases with an increase of the speed of the driving shaft. See, when the speed of this driving member is slow, this driven member, that is turbine shaft, will not start rotating, or turbine blades will not start rotating. But once it will gain a certain speed or gain a certain RPM, the fluid will go and strike with such force that it will also start. Okay, and after once it will strike the turbine blade, it will again flow back to the pump impeller side and from the center, and in this way the circuit got complete. This is the line diagram, or we can say the layout of fluid coupling. Here, this arrow is showing the flow of fluid, that is oil. This is our crankshaft. This is our fluid which is moving like this. So this is in right side. This is pump impeller. Pump impeller fluid uh, goes out circumferentially and will strike. This half is turbine runner, or we can say driven rotor. When the fluid strikes at the outer portion of the turbine runner, it start rotating and the fluid travel like this and will come from the center and goes back to the pump impeller, thus completing its hydraulic oil circuit. So in this way, the fluid coupling works and the power is transmitted from driving shaft to driven shaft. Now, let us see what is the efficiency of fluid coupling. Consider that the speed of driving member and driven member is given by omega I and omega O. That is I for inlet and O for outlet. So it is input shaft, this is output shaft. So this is driving member RPM and this is driven member speed. And not in RPM, it is in radian per second. And tau I and tau 0 with the corresponding input and output torque on the shaft. Then the efficiency, what is the efficiency of any device? It is output upon input. So here also the efficiency of this turbo machine will be power output upon power input. So what is power output? Power output will be the multiplication of torque at output shaft to the speed of the output shaft. And what is the power input? It will be the multiplication of torque of input shaft to the uh, speed of output input shaft. So it will be tau 0 by tau 0 into omega 0 by tau I into omega I. So this is our efficiency. See here negative sign is there. Why it is there? Because when we stand in between the two pump impeller and turbine shaft and we will look, we will see that both are in opposite direction. When we see pump impeller, it will rotate. If it will rotate in clockwise direction, and then we will see the turbine, it will we will see that it will rotate in a anti-clockwise direction. Okay, so the rotation we will see, we will visualize that it is opposite to each other. That's why there is a negative sign, because omega and omega 0 and omega I are in opposite side. Okay. Now see what is happening here in fluid coupling. The torque is only transmitted from input to output, and there is no multiplication or reduction of torque. Same torque is transmitted from input shaft to the output shaft. So tau I and tau 0 are same in fluid coupling. So it can be cancelled out, and what we will get? We will get that efficiency is the ratio of angular speed of output shaft to the angular speed of input shaft, that is omega 0 by omega. One more very important term is related to fluid coupling, that is slip. So what is slip? Slip is slip of any turbo machine, or you can say that slip of fluid coupling is defined as the ratio of difference in speed of the driving and driven shaft. See what is happening here. The driving shaft is rotating with the speed of omega I, and the speed with which the output shaft is rotating or the turbine runner blade is rotating, they are not equal. There is some difference between the speed of the two shafts. Why it is? Because 100% transmission of power is not possible, 100% efficiency is not possible. See, if this omega 0 and omega I will become same, then what will happen? The efficiency of the turbo machine will be 100%, and it is not possible for any machine to deliver 100%. So here always there will be a omega 0 less than omega I, which will be around, the efficiency will be around 95% or 97% or 90%, anything like that. So what we will see, we will see that the output speed of the shaft, speed of the output shaft will be less than the speed of the input shaft. So slip is the difference of that speed, means input shaft speed will be more. So input shaft speed minus output shaft speed to the input shaft speed ratio. It is the ratio of difference between the speed of the input and output shaft to the speed of the input shaft. So it is defined as the ratio of the difference of speed of driving shaft and driven shaft to the speed of driving shaft. That is omega I by minus omega 0 by omega I. Now this can be written as 1 minus omega 0 by omega I, and omega 0 by omega I is known as efficiency. So there is a relationship between the slip and efficiency of the fluid coupling. That is, slip is 1 minus efficiency. If the efficiency of this turbo machine, that is fluid coupling, is 95%, that means the slip will be 5%. Okay, so this is about fluid coupling. Thank you. Thank you.